Welcome. We now begin Chapter 9, titled Hypothesis Testing of Two Populations, and we'll be considering cases of independent and dependent samples, but let's just first get a general overview here. So studies are often done to compare two groups. For example, perhaps we'd like to investigate the proportion of students that are satisfied with on-campus food services as compared with proportion of faculty who are satisfied with on-campus food services. So our two populations there comparing students with a second population, faculty. Or as another example, we might want to compare heart attack rates for two groups, where one group is treated with aspirin and the other group receives a placebo. All right, so in order to investigate claims about two populations, our samples can either be independent or dependent. So two samples are independent of each other if the sample values from one population are not related to or somehow naturally paired or matched with the values of the other population. So for example, if I polled a student asking them about their satisfaction with food services, and then I wanted to also poll a faculty member, the student and faculty member would be independent of one another because the faculty member selected would not be based on the student that was selected. So that's what independent means. So you can think of them as two separate populations where one is not linked to the other, versus dependent samples. These are often referred to as matched pairs. This is when our measurements are linked or related. So for example, we could have a study on two measurements, but they're taken from the same subject. So we could have like before and after data. So like a person's cholesterol before starting a new diet, and then their cholesterol after. So those two measurements would be linked. Or we could do sample values of matched pairs where the matching is based on some inherent relationship, so such as studying twins. All right, so our first step then, as we investigate two populations, will be to look for claims and write our hypotheses. So number one, researchers believe the mean annual income of child care workers in California is greater than the mean annual income of child care workers in Oregon. All right, so we have one population of workers from California, and they believe that that mean is greater than the population of child care workers in Oregon. So because we have two populations, we will be indicating population 1, population 2 with subscripts on our parameter. So we will start with our claim. So our claim as our alternative hypothesis is that the mean for population 1, California workers, is greater than the mean of population 2, our Oregon workers. And because that is a greater, this is a right tail test. So lots of similarities to what we've done in the past. Now just moving into two populations. The null hypothesis will always get equality. And as always with hypothesis testing, we'll assume that the means are equal, but then go out and gather evidence to argue against that in support of a claim that the mean is greater in California than in Oregon. All right, let's do another one. Number two, researchers claim the mean recovery time from a cold for patients treated with a multivitamin is less than the mean recovery time from a cold for patients treated with a placebo. So we have one group getting a multivitamin, that's our first population, and they claim that is a smaller recovery time, less than for those in our other population, people receiving placebos. All right, so we'll let mu1 be our first population, the multivitamin users. So our claim is that the mean for multivitamin users is less. and the mean for those receiving a placebo. So that less than makes us a left tail test. And null hypothesis, always a statement of equality. All right, one more here. Number 3, veterinarian claims that the proportion, so we're switching to a different parameter here, not mean, proportion of dog owners who brush their dog's teeth regularly. So our first population, dog, I guess the dog owners, not the actual dogs. So dog owners who brush their dog's teeth regularly differs, not equal to, differs from the proportion of cat owners who brush their cat's teeth regularly. So we'll let the population proportion for population 1, P1, be the dog owners. So our claim now is that proportion for population 1, dog owners, differs, is not equal to the proportion of our cat owners who regularly brush their cat's teeth. And that makes it a two-tailed test. All right, null hypothesis gets equality. All right, so after we write our hypotheses, the next step will be going out to get some data and testing these claims. So when we conduct a hypothesis test of 2 populations, and we'll be working first with independent samples, we'll do the case where the population standard deviations are known. So we'll do those cases first, and then we'll move to population standard deviation unknown second. If we know population standard deviation of our 2 populations, then we'll be able to apply the 2 sample z-test on our graphing calculators to find the test value or test statistic. So I did include a by hand calculation here, which isn't necessarily hard. It's just a little bit tedious. So we'll be able to get our test value on our calculators a little more efficiently. And then when we conduct the test, we actually collect our sample means and look at the difference between them. So our null hypothesis here, let's just go up here for an example. Our null hypothesis for the multivitamin placebo group, if the 2 means are equal, just going to add another way of saying that. So if the 2 means are equal, that means if we take population mean 1 and subtract population mean 2, if the values were equal, then the difference between those would be 0. So when we conduct our hypothesis test, the picture of the null hypothesis will be that the difference between the means is equal. And then we'll go out and get some sample data and see if we get something close to a difference of 0 or something further right for a right tail test, left tail test, further left, or a two-tailed test in either direction. So again, lots of similarity to what we've done in the past. So in order to, again, conduct a 2-sample z-test, we need sigma 1 and sigma 2. Our populations that we're drawing our samples from, we need sample sizes that are reasonably large, or the original parent populations we're told are normal. And this will be our case of independent samples. And then we'll go ahead and take a look at some examples.